Hi everyone, good afternoon to all. We just want to uh, explain about the 8051 architecture. We'll just discuss about this one. The topic in this 8051 architecture is Introduction to 8051. Here in this case, we will be just elaborately we'll be see about central processing unit, that is CPU, interrupts, memory, bus, and then oscillators, input output ports, timers, and then counters. In this 8051 architecture explanation, in the 8051 architecture, it has been designed by in 1980s. It is based on the Harvard architecture and it is developed for the embedded systems technology. Here, it is a technology like so much of technologies are there like CMOS, NMOS and all. So in this one, the 8051 architecture is based on the NMOS technology, which requires more power to operate here. It has two buses, one is and two memory spaces, 64K into size for program and then data units. Here in this one, we'll be seeing about program memory separately and then data memory separately. It has an 8-bit processing unit and it 8-bit accumulator unit. Accumulator unit means like it is a register. Like a register you will be having, it is a temporary storage process. So it is an 8-bit one. So that is called as an 8-bit accumulator unit. It has an 8-bit processing unit. What does that mean? Processing, like you can be the processing and all, like registers you are just saving, you will be doing some arithmetic operation and then logical operation, and then you'll be going for some other functions or projects, anything else. It is based on your 8-bit processing unit only. That is the meaning of that particular line. Fine. We'll come to the next slide. This is the basic architecture. We'll see it has A register over here and then B register and temporary register and then PC, DPTR, everything, EEPROM, RAM, instruction registers, PSW and then timer and control unit, everything is there. Here coming to this point, like the right side, you will be having latch 0, 1, 2 and 3, and this has been connected to your port 0, port 1, port 2 and then port 3. What is that port? We will be having four port here, namely port 0 to port 3, port 0, 1, 2 and 3. Here in this one, port 0, port 1 and port 3 will be used as for your general operation like arithmetic, logic, bitwise and bit manipulation. For that and all, you will be using that port 0 to 2. In that port 2 is a special one. It's not only special, like it is a 16-bit one because we can able to handle only 16-bit address or then data. So that is what the higher order things will be in your port 2 ports. Like in port 3, what does that mean? It is also a port. It can also handle 8-bit of operators. Like this can handle up to 8-bit, and it is a name called as a special function registers. Those special function operations and all will be done in the case of port 3. So that is what the all SFRs, that is the special function register operation, will be done in the case of port 3 register. Fine. What is that A register and B register and then temporary registers? The A register is nothing but it is an accumulator. Accumulator in the case in whether it is a processor or controller, whatever it may be, it is a temporary storage device. As we all know, like in the previous videos itself, we can able to understand like A register is an accumulator register. Okay. In the right side of that block diagram, we'll be able to see like ALU, arithmetic and logic unit, RAM, ROM, PC, program counter, SP, and then registers, interrupt circuit, timer or counter, and then input output ports. In this program counter, PC and then DPTR, you can able to see in this case of here. These two are 16-bit operators. 16-bit, we can able to handle up to 16-bit. That is what we'll be saying, like that is what we'll be handling, like the higher order address and data in this case of port 2. So the input output ports and all we have seen like port 0 up to port 3. Like in depth arithmetic and then logic unit is like it has been monitors and controls all the operation that are performed on the microcontroller unit. The user has no control over the work of the CPU. So that is what it is, a predefined one, like it is a processor or controller, whatever it may be, it is a predefined one. It reads the program written in ROM memory and it executes them to do an expected operation or expected task that is based on your application. Like interrupts gives a mechanism to put on hold on ongoing operation, and execution is subroutine, and then it again resumes to another type of operation. See, for example, the interrupt is nothing but, say, for in real time uh, operation also, if you are just doing any kind of work, if the any interrupt is coming or any important work other than this it is been coming, means we'll be just concentrating to that one, and again we'll be resuming the uh, what we are doing now in general. The same thing, the interrupt is also the same thing in the case of interrupt also. The interrupts gives a mechanism to put on hold. What is that being hold? In the case, it is the hold means like you just pushing some address to that particular stack, and you will be doing what is coming inside. What is the interrupt that has been coming inside? You are just obeying your concentration over there, and then again you are just resuming that process. That is, you are just popping up the thing, and again you are just continuing your work. This is the main uh, task of your interrupt. The bus is nothing but you'll be having two buses, like one is address bus and another one is data bus. The address mode refers to how you are just addressing a given memory location, and then data bus is nothing but which has been used to carry the data of particular application. The next one is general purpose registers, program counter and stack pointer. In this, the program counter holds the address value of memory of to the next instruction to be executed. It is a 16-bit register. As I already told you, like DPTR and then program counter are the two registers we can handle up to 16-bit. Here in the case of temporary register, instruction register and decode, timing and then control unit, all the cases are there, like interrupt control, everything. And this is the addressing mode of 8051. And the assessment questions are, which of the following commands will copy the contents of the location for which to the accumulator, and L call read. These things and all, if you are just concentrate in the addressing mode, then you can able to answer very well. So here we'll be having 9 MCQs questions for assessment questions, and we'll see the next video, the next topic in the next video. Thank you.